Okay, I'm going to make now a second one. I'm going to start from the beginning. This is 4th grade. I'm not sure this is the best beginning, but let's see this place value. It's time to master place value. In this unit, you'll use blocks and tables to learn all about expanding, standardizing, and writing numbers. You'll also sharpen your skills in comparing and regrouping whole numbers. Place value. Up next. Place value blocks. What is this? Place value. What number is shown by the place value blocks? Wow. 2. What is this? Not quite. What number is shown? Place value blocks. Identify value, creating the largest number. Wait, let's check math, early math, counting, addition, subtraction, place value, addition and subtraction. Second, add and subtract. Data within 20. Intro to multiplication. Addition to what's 3rd grade? Intro to multiplication. You'll learn how to combine equal groups of numbers to find the total. And even how to use arrays to draw out what you're doing. You'll learn all about what it means to combine equal groups of numbers to level up your math skills. So that's grade 4 actually. This is grade 3. Let's see this. Equal groups. Use the image below to help fill in the blanks. There are, I have to count. 1, 2, 3, 4, 5, 6. There are 6 sixes. So there are 1, 2, 3, 4, 5, 6. So there are 6 bananas in all. Check. Groups. What is this? See, is this confusing? Now I have to watch a video.
What we have here are pictures of running pigs, and we could try to figure out how many running pigs there are by just counting the pigs. But we're going to start building some new muscles. And this muscle is going to involve, hey, if we group the pigs into equal groupings, can that help us figure out how many pigs there are? And you can see that I have groupings of 7. Each of these groups are 7 running pigs. So how many total groups do I have? Well, I have 1, 2, 3 groups of 7 running pigs each. 3 equal groups. So if I said, what's the total number of running pigs that I'm dealing with? Well, I have 3 sevens. 3 groups of 7. And so that's the same thing as 7 plus 7 plus 7. And if you wanted to figure out what that is, you could skip count. If we skip count by 7, we go 7, then 14, then 21. And so 3 sevens, which is 7 plus 7 plus 7, is 21. So there's 21 pigs here. And you can verify on your own that if you count this, you will indeed see 21 pigs. Let's do another example. So here I'm looking at a picture of a bunch of blue seals, not something that you're likely to see.
Yeah, I'm kind of doing, this is still very random. I don't know if I should just start from the beginning. Like here, I have to use my eyes. Well, no. Yeah, where's the courses? Algebra basics. Is it algebra basics? Foundations, linear equations and inequalities, graphing lines and slope, system of equations. Equations and geometry. Foundations. What's the foundations? Check this. This topic isn't algebra, but it's a survey of all the most important pre-algebra skills you need to really digest algebra. These skills also tend to be pretty important in life. Intro to negative numbers. Negative numbers on the number line. Where is the blue dot on the number line? 0, 6. Again, I have to use my eyes. 6, 12, 6, 12, and 18, right? Yeah. Move the dot to 12 on the number line. -4. Yeah. These are very like 4, 8, 12. Yeah, I don't know how I would present this with Haskell. 4th grade. Get ready courses. Pre-K Con Kids Early Math Review. 2nd grade. What's the second? Multiply by one number. Place value. Oh, the place value thing. Check again this place value. Identity. Wait. Identity factors. What's the identity factors? Which equation shows that 8 is a factor of 32? Yeah. Like the factor of 32s. Which equation shows that? Which equation shows that 8 is a factor of 32? Am I still recording? Oh. Which equation shows that 8 is a factor of 32? 8 plus 24. Finding factors of a number. Understanding factor pairs. Eight plus 24. I don't understand this question. Which equation shows that 8 is a factor of 32? Oh, D. Because 8 times 4 is 32. Yeah. List all the factors of 56. Choose one answer. Okay. So we have the factor pairs and factors. Where's our factors 16? Okay, factors. We just have a list factors of 56. So we have factor pairs, but we can also have 220 factor. These are aligned. These are sorted, and these are also sorted. 1, 2, 4, 7, 8, 14, 28, 6, 1, 2, 4. Yeah, this is cool. 1, 2. So list all the factors of 56. So that's this. 1, 2, 3, 6, 1, 2, 4, 7. Check. Which of the following numbers is a factor of 49? Factor, oh, it would be, okay. So if I write this, I get 1, 7, and 49. That's 7. But how do I write a program that will, which of the following numbers is a factor of 49? So like, could I write a program like factor of 49, factor of 49, 7, and then it gives me true. Yeah. How would we do that? Like I want a simple Haskell program that would give me a Boolean true or false when I provide a number and ask if such a number is a factor of some number. The example would be factor of some number. The example would be factor of 49, 7. And then Haskell would check if 7 is a factor of 49 and give me a true. The checks in one number is a factor. So, right, so we have like a, which of the following numbers is a factor, identity factor? Is called identity factor, I guess. I don't know. What's this? This is Unit 6, 4th grade, Unit 6. Fourth grade, Unit 6, identity factor. So, which of the following numbers is a factor of some number? One of the test questions was, which of the following numbers is a factor of some number? Now let's say we write a Haskell program that would give a true or false when we ask if such a number is a factor of such a number, of some number. So let's see. Factor of. Define the function factor of. Factor of is a function that takes an argument of type int and gives, oh yes, takes an argument of type int and specifies it takes two integers and returns a boolean. It takes two integers, yes, and returns a boolean. Factor of n of x equals n mod x. N mod x. Or maybe could we do, how would we do it without the n? If n mod x is 0, find the function factor of. Yeah, that would be, that makes sense. Find the function factor of. Factor of 7x. So factor of 7x equals, right, 7n mod x equals 0. Factor of 49 and 7. True. So what do we have? Which of the following numbers is a factor of 49? Oh, but he gives us wrong answers. Okay, and so Khan Academy gives us 4 possible answers. Okay, let's check. So we are provided by 4 possible answers, and some of those is, and some of these is wrong. Now I want to be able to provide, to give as an input a list of such numbers, and then Haskell would give me back that list of numbers and add bools like, or maybe like a tuple of sorts. So like such a number, true. And then such a number, false. Is this possible? Define the function that checks if a number is a factor of another number. Yeah, we did define the function that takes a list of numbers and a number to check against. Check factors. Factor. And now we're taking this function, check factors. Check factors and a list. Let's try this. So we have factor of, check factors and a list of x's. Now we have it the x. Oh, that's the x factor of n of x. Factor of n of x. X takes a list of x's. Wow, is that it? Check factors. 49. And what's the list that we have? 4, 2, 7, and 9. 4, 2, 7, and 9. 4 false, 2 false, 7 true, 9 false. Well, this is interesting. So that would be check factors. Yeah, I mean, I could do all this on my own without the chat GPT, but I just think it would take way too long time. I think it's even better to just, do this and then learn from it. I don't know. Not sure if this is the right methodology. So now we want to check, but what if I want to... So it's possible to write a Haskell function that takes a list of numbers and returns a list of tuples where each tuple contains the number and a Boolean, indicating whether it is a factor of a given number. Yeah, this is what I want to copy. Han asks, write a Haskell function. This is because in the test, we are given a list of numbers, but some of those are incorrect solutions. So how would we write a program that would somehow encapsulate, that will give that information as well? Good. Function takes a number n and a list of numbers x's, returning a list of tuples. Each tuple consists of a number from the list and a Boolean indicating whether it is a factor of n. Yeah, this kind of Learning math would be completely different, yeah. The list comprehension, x factor of and x constructs the list of tuples. Oh, this is the tuple. First is the x, and then is the factor of x, and the x, it goes the list. This is very interesting, yeah. In the main function, we define number to check as the number we're checking the factor against, and list of numbers as the list of numbers to check. We then call check factors and print the results. This is nice what he did. Like let results, check factors, numbers to check, list of numbers, print results. Wow. So what's the solution? Check. Did we check? No. 4 is false. 2 is false. 7 is true. And 9 is false. Which equation shows that 5 is a factor of 45? So we could do the same here. Check factors. 45. And we have the factor of 45. We should provide it that 5 is 5 true. But which equation shows that 5 is the factor of 45? Yeah, this will be more, I guess, complicated to put in Haskell. Which equation shows that 5 is the factor? Well, 5 times 9, I guess. List all the factors of 48. So that's our old friend, factors, factor 48. 1, 2, 3, 4, 6, 8, 12. 2, 3, 4, 6, 8, 12, 16, 24. So see, we have like 3 functions that we can use. Which of the following numbers is a factor of 55? Now we want to use factor of 55. Factor of 55. Oh, we have to give it a list. 5, 3, 6, and 7. 6 and 7. Factor of 55. What was the factors? Factors of, check factors. Factor of 55. Oh no, check factors, we said. Check factors. 55. 5, 3, 6, and 7. 5, 3, 6, and 7. 5 true, 3 false, 6 false, 7 false. So 5 is true. 5. Yeah, it's like changes, like it's more interesting to work on a program than kind of solve things. This is what I noticed. Like here, I'm solving more and more stuff, and maybe maybe that's why some of the kids are like, it's too much for them. It's too much for me. And like with programs, you kind of describe the properties, you describe how the function works, which eventually becomes more important. We can let the computer compute, and we should understand in an abstract way how factoring works. You see, by the like, they don't even know what's a factor then. By like I forgot. Yeah, I'm not really the best example. Yeah, I guess it's clear. Yeah, I'm just trying to put into words maybe some kind of a frustration of sorts. Which equation shows that 9 is a factor of 72? So we have again factor of 72 and 9. Factor of, just a moment, my cat climbed up. Which equation shows that 9 is a factor of 72? 72 times 8 is 9. Yeah, it's this. Not quite. I made a mistake. 9 is... I was thinking... Which equation shows that 9 is a factor of 72? Also, there are different equations. 72 divided by 9 is 8. This, yeah. No! I made a... Awesome, you leveled up. Standing up next week. Finding factors, reasoning about factors and multiples.
We're told we know that 5 times 3 is equal to 15. Yep, that's true. So which of the following statements are also true? And it says to choose 2 answers. So pause this video and see if you can work through that. All right, now let's go through them one by one. So this first one says 3 is a multiple of 15. Now, in order for 3 to be a multiple of 15, that means that we can multiply 15 by some whole number to get to 3. But a multiple of 15, we're thinking 15, 30, 45, it's not going to be 3. What whole number can I multiply 15 by to get 3? If I multiply 15 by 1, I'm already at 15. So this is not going to be our choice. And since they say pick 2 answers, well, we might be able to figure out it's these, but let's just read them to make sure that they make sense. 15 is a multiple of 3. So that means I can multiply 3 times some whole number to get to 15. And we know what that whole number is. It's 5. They tell us right over there. 5 times 3 is 15. So 15 is a multiple of 3. 15 would also be a multiple of 5 because I can multiply 5 by the whole number 3 to get to 15. So I like this choice. 5 is a factor of 15. Well, factors of a number are numbers that you can multiply together to get that number. So 5 is a factor of 15 and 3 is a factor of 15 because 5 times 3 is 15. So this one is also true. It would have also been true if they said 3 is a factor of 15 or if they said 15 is a multiple of 5. Any of those would have been true statements based on what we know that 5 times 3 is equal to 15.
All right. Finding factors and finding multiples.
Which of the following numbers is a factor of 154?
Yeah,
so a number is going to be a factor of 154 is if we can divide that number into 154 and not have a remainder. Or another way of thinking about it, a number is a factor of 154 if 154 is a multiple of that number. So let's look at each of these and see which of these we can rule out or say is a factor. So does 3 divide evenly into 154? Or another way of thinking about it is 154 a multiple of 3? Well, you'll later learn that you can actually test whether something is divisible by 3 by adding up the digits. And if that's divisible by 3, then it's going to be divisible by 3. And so you see here 1 plus 5 is 6, 6 plus 4 is 10. 10 is not divisible by 3. But if you didn't want to do that little trick, and we have other videos we go into more detail about that trick, you can actually just divide 3 into 154. 3 doesn't go into 1. It does go into 15 5 times.
These kinds of tricks, I think, are for some people.
Subtract. Then we have 0. Then you bring down a 4.
This is so manual. 19th
one time. 1 times 3 is 3. Subtract. And you have a remainder of 1. So 3 is clearly not a factor of 154. So we can rule that out. Now what about 5?
Yeah, but it's...
Well, any multiple of 5 is either going to have a 5 or a 0 in the ones place. You see that. If 5 times 1 is 5, 5 times 2 is 10, 5 times 3 is 15, 5 times 4 is 20. You either have a 5 or a 0 in the ones place. This does not have a 5 or a 0 in the ones place, so it's not going to be divisible by 5. 5 is not a factor. 154 is not a multiple of 5. Now 6 is interesting. You could do the same thing. You could try to divide 6 into 154. But if something is divisible by 6, it's definitely going to be divisible by 3 because
it's taking long.
Bring down the 4. Which of the following numbers is a multiple of 14? So now we have 14 and we're trying to think of its multiples.
Which of the following numbers is a multiple of 14? How would we implement that? Let's implement this. Which of the following numbers is a multiple? Is a multiple of what? Multiple of 14. So I'd like to provide you a list of numbers again, which are what? 69, 70, 75, 69, 70, 69, 70, 75, 80, 85, 75, 80, 85. Let's see. Is multiple of 14 is multiple. Let's write it with list comprehensions without naming a function. Let list of numbers and the x's. Let results. So the x mod 14, if it's a multiple of 14, and without the mod, x times x mod 14. Always this mod makes things really, I don't know when is the mod learned in school. Mod, yeah, but this would be a reason to really learn about mod earlier. So we would have like x. No, yeah, of course, because it's a pair. X and x mod what? X mod 14, 0, then a pipe will, okay. And now into the x we'll put what? The list of numbers. And the list is what? 69, 70, 75, 80, 85. And we get. So let's check this again. Finding factors and multiples. Which of the following numbers is a multiple of 14? Following numbers. Multiples. Which of the following numbers is a multiple of 14? 69, 70, 75, 80. 85. So Haskell. And what do we get? We have a list of numbers, yes, but we're going to make something simpler like this. How do we do it without the mod? Can we do it without the mod? Can we do it without the mod? Without the mod and using basic Haskell. Can we do it without the mod? Not from integral. Okay, stop putting it into functions. I want something that can be tried out in the interpreter using just list comprehensions and basic operations. From integral. Yeah, because this is more complicated. List of numbers, 69. Yeah, we have a list. And then results are what? X from integral x times x divided by 14. From integral. Yeah, I'm not. Uses a list comprehension to create a list of tuples. Each tuple contains a number x from a list of numbers, and a boolean indicating whether x divided by 14 results in an integer. So this is the predicate. Basically, this entire field is predicate. No. Simplify. Okay, x divided by 14 times 14 equals x. This is, oh, this is instead of mod. X list of numbers. Let's try this. What do we have? Again, we have this x and x div divided by 14. X mod 14 is 0, so it's same as x div 14. Wait a second, let's check something. X mod, let's try x mod 14, wait. Let's try. I want to compare x mod 14. Wait, let's try again. X div 14 times 14 is x. And into the x, we're going to put a list of numbers, which are 69, 70, 75, 80, 85. And we get the same result. All right, let's copy this. I'm going to copy this and then check it later. Haskell. Another variation without you using the mod function.
So there's two ways of doing this. You could go number by number and try to divide 14 into them, or we could just try to figure out what all of the multiples of 14 actually are. So let's try to do that. Let's try to do that second technique. 14 times 1. 14 times 1 is 14. You add another 14. 14 times 2 is 28. Add another 14. Let's see, you add 10, you get to 38. Then you add 4 more, you get to 42. Then you add another 14. I haven't seen any of these numbers show up yet. Add another 14 to this, you get to 56. Still not quite there. Add another 14. Let's see, if you add 4, you get to 60, and then you have to add the 10. So then you get to 70. And it looks like we have found one of these numbers. 70 is a multiple of 14. 14 times 1, 2, 3, 4, 5. 14 times 5 is 70.
Wow. I kind of missed this. Next exercise. What is a multiple? Look, the first question was, what is a multiple? Let's go. Wait a second, wait a second. Let's go back actually, finding factors. What is a factor and what is a multiple? A number or quantity that when multiplied with another produces a given number or expression. Multiple, a number that can be divided by another number without a remainder. Is there an easier way to do this? There are a lot of tricks you can use, as Saul does in most of these videos. If you search up divisibility tricks, you might find some. Yeah, why learn tricks? You know, is there an easier way to do this? Yes, learn Haskell. Ready to practice? Let's go. What set of numbers are shaded on the 100 chart? Wow. Oh, I have to use my vision for this. What set of numbers are shaded on the 100 chart? Wait, how long was this already? Yeah, I'll stop here. This was very interesting. I think I'm going to keep up with this. Yep, I'm going. This sounds like a very long-term project. Do not disturb mode active. All right, but yeah, I think it's worthwhile. Nice, beneficial.